NATO's maritime forces are facing increasing pressure to protect NATO allies from possible threats at sea or from the sea. In order to meet new security challenges, many NATO nations are undergoing a fleet modernisation programme.
We need new ships, cruisers, destroyers, frigates. We need submarines. We need to strengthen the anti-submarine warfare capacity, because other nations are putting incredibly quiet boats in the water. That threatens the security of NATO nations if we can't counter that. So NATO forces have to be modernized. Naval ships are expensive and they're hard to design, so we want to be able to design them better for better operational effectiveness and affordability.
Warship design is a lengthy and difficult process during which numerous factors need to be considered. What mission will the ship undertake? How big does it need to be? What weapon systems does it need? Will it need a helipad? In order to achieve operational effectiveness and affordability, there will be trade-offs.
When you talk about a military ship, you're talking about weapon systems that are extremely sophisticated in of themselves. So a sensor that's trying to find something on the horizon while the ship is rolling left to right, bouncing up and down in the fog, in the rain, and it's trying to understand what it sees as the Earth bends over the horizon. So we say, well, let's put the antenna sensor way up on the ship. Oh, I can see farther now. Well, that causes the weight of the ship to go up. So there's a trade-off to be made. So what we want to do is we want to understand what those trade-offs are.
A NATO task group made up of scientists and naval architects has been looking into how NATO nations currently design warships and how that process can be improved by using novel software tools.
What we wanted to do with the group was be able to look at a wide range of options what those future warships would look like. What we found was that the different nations involved did have the different bits and pieces for the process or the tools, but no one had the complete process and tool set figured out. So the objective of the research task group was go and develop both the process and the tools so we can look into a wide range of alternative warships early on to inform the discussion on capabilities, budgets and requirements.
The research has combined information from various warship design models used by NATO allies and created new models to help nations make better informed decisions.
It is software. The tools are software tools. They're integrated, so what you do is you play around with the speed of the ship, if it has a helicopter or not, or maybe two, which of course is going to affect the ship size itself and the cost. And you might have different weapon systems that you can choose from, which are all going to impact the ship size and the ship cost. Ideally, something would come out like, okay, you need to have one helicopter, it has to go this fast, and it's going to cost this much, because then you're right on a budget line and you have the highest amount of effect that you can get for that money.
NATO allies currently using this new software include Italy, the Netherlands, the United Kingdom and the United States, which is helping to benefit a core principle of NATO, collective defence.
It will help us marshal our resources in a way that allows us for an ever increasingly squeezed budget and to work collaboratively to handle the future security needs of each of the nations.
If you think about multiple nations using the same basic design tools, you will begin to then design in interoperability. So you'll be able to understand how one warship from country X and maybe a different type of warship from country Y can interoperate. So you then begin to think of not just a single country ship, but a whole armada of ships from different nations operating together for the best possible outcomes.